Hello, everyone. My name is Ron Sayler, and I work at Haas Hall Academy in Bentonville. I teach environmental and physical sciences, among others, and Strive has allowed me to been instrumental in bringing the applications of science in manufacturing into the classroom. I was placed at GLAD Manufacturing in Rogers, and I learned the process of manufacturing disposable projects like trash bags in the GLAD manufacturing plant in Rogers, Arkansas. Identified STEM and engineering applications in industry that translated to my STEM classes. Identified a low-cost method to identify and reduce energy costs in overheating the plastic film extrusion unit. The GLAD manufacturing plant makes trash bags. To do that, they melt plastic and produce plastic film by blowing the melted plastic through a large tube that makes a bubble that's cut into strips that's made into trash bags. During the summer, our placement, the temperatures were over 100 degrees. This heat translated and transmitted into the building, overwhelmed the AC units, and negatively affected the quality of plastic film production for trash bags. So identified a way to reduce the albedo, which is to increase the reflectivity, which is the albedo of the roof, and reduce the temperature inside the plant. And here shows the black roofs where the extrusion towers and these bubble film production occurred. After suggesting that, I developed a laboratory lesson plan based on this to measure the difference between light and dark colored roof shingles in terms of temperature increase, which is a measure of albedo, and thermal energy transfer. So high albedo causes high reflection, low albedo, low reflection, high absorption. And so that's the definition of albedo. I developed a lab based on this for both environmental and physical science classes, in which students monitor the temperature of a brown and white shingle under heat lamp for 30 minutes and took measurements every 2 minutes. Here we see a student on the right using this, playing with it and experimenting with it on her hand. This is a thermal imaging camera, as well as a student below taking temperatures with a temperature gun of these different shingle pieces under the lamp. They learned the appropriate use of controls in this experiment. They developed a graph of temperature versus time for both shingles, along with appropriate controls. They wrote up lab reports based on this, and here's an example of an increase in temperature and thermal energy of the darker shingle on top in green versus the lighter one in yellow, as well as the white paper controls in the two lines, red and blue, below that. In this process, I had students take pre and post tests for albedo and energy conservation, as well as environmental science topics, and they improved greatly after doing this lab by about at least 30 percentage points on these pre and post tests that I gave students. They also learned to use the equipment for standard energy audits of the home and businesses, as well as preparing the lab reports on this. So Strive allowed me to significantly expand my hands-on teaching ability in the classroom through the provision of resources by the Strive grant, and it's allowed me to teach students real-world examples and help them learn about what's going on in the industry and the jobs that are available.